Hello everyone. So for this playlist, I'm going to cover recursion and backtracking, mostly focusing on backtracking because recursion, you might know. Okay, so recursion is anyways very simple. If I could explain you with a simple Fibonacci series, then you know that for generating the Fibonacci series, our first number is one, and then third number is combination of the previous two numbers, which is one plus one two. And then again for the last from the last two numbers, two plus one will get three, and from 3 plus 2 5, and from 5 plus 3 8, and so on and so forth. Okay, so this we could generate with the help of the recursion. Now how could I generate it with the help of the recursion? So let's understand with the diagram that what actually the recursion looks like. Okay, how you will face it. So let's say you will be given some number n, so you have to find for number n the Fibonacci nth number of the in the Fibonacci series. Then you know that you have to find for n minus 1 and n minus 2, and then you have to add this two. Okay, now again for n minus 1, what you want? For n minus 1 you will want n minus 2 and n minus 3. So minus 1 and minus 2 of this, and here n minus 3 and n minus 4, and you will sum this, and this you will go on until which point? Until base condition point. Now what is my base condition? Base condition is something, so let me write it over here. Base condition is a point at which you know your answer and you can return from there. So I didn't wanted to explain you in detail, but let's say in Fibonacci series, what is the number? What is the point where you know the answer? So you know that Fibonacci zeroth number is 1 and first number is 1. If I could start from 0, if I could start from 1, then 1 is 1 and 2 is also 1, like that. Okay, so you know this base condition. So this is the base condition. So until the point you reached where you have found that your number n is 0 or 1, then what? You will return simply 1, because 1 is the answer if n is 0 or 1. Otherwise, you will call for n minus 1 and n minus 2, and you will add up those two numbers to generate a Fibonacci sequence. Correct? Okay. So this is simply the recursion. Okay, recursion is nothing but calling calling the same function inside a function. Okay, so my Fibonacci of n is nothing but I will call the same function for n minus 1 and n minus 2, and then I will return the summation of this 2. Okay, so this is the recursion. Now, what about backtracking? What about backtracking? So, backtracking is nothing, it's an algorithm that finds a solution incrementally by trying different options. Okay, and undoing them. So now there could be possible that for finding the solution of this, you have two or three different paths. Okay, you go here, you go here, you go here. Okay, and then again you go here, you go here. There are two paths from this point. There is only one path from this point, and there is again one path from this point. Okay, but you didn't get the answer from here. Now there are no more paths. Okay, then what you will do? You will return from here, or you will backtrack from here. So you again came to this point. Now you will move to this path. Again, you didn't find any solution. You will return. Okay. So now there are no more paths. There are only two paths which you have already visited, which you have already traversed. So now this will also backtrack. Okay. This will also backtrack to the original. Now this path is traversed. It will move on to this path. Okay. Again, it will explore this path until the deepest point. Okay, this point it has got the solution, it will return and it will not move to this path. Okay, but until the point it has not moved to this path, it will follow all the solutions, all the paths, it will expand all the paths. If we are not getting the answer, we'll backtrack it, and if we have to find all possible solutions, then you will push this to your main answer. You will again backtrack, you will come here, you will come here. If this is also solution, you will push it and you will backtrack and come here. Now there are no more paths. So in some data structure you have stored these two solutions and you will return this. I hope you got. A simple meaning of backtrack is to push and pop. push and pop. Once you get the solution, you have push it, pop it, push it, pop it. Not the solution. If you have found the path, if you have expanded that nodes, you'll push that, you'll pop that. Okay. So when to use this? Okay. Let's see when to use this kind of, when to use backtracking algorithm. So first point, when there are multiple possible solutions, when there are multiple possible solutions to the problem. We'll see one problem today and you'll get a better idea of this. When there are multiple possible solutions to the problem, we'll use backtracking. When problem is broken down into smaller subproblems, then again we'll use the backtrack algorithm. And that subproblems could be solved independently. So these are the three main reasons of using the backtrack algorithm. If we could solve each subproblem independently, so we have solved this subproblem independently and we didn't find the answer. We'll return from here, we'll pop it out, we'll backtrack it. So this is simple concept of backtracking. Now how to use it? How to use it? So we'll choose one initial solution, okay? Explore all possible extensions to that from current solution, I could say. So you choose one initial node, you explore all possible extensions. You might know the DFS algorithm, so this is similar to DFS, depth first search in the graph. Okay, explore all possible extensions from the current solution. If that extension lead to possible solution, push it or return it. Otherwise otherwise backtrack it and then repeat until all solutions are found. So this is the simple way of going with the backtrack algorithm. Okay. Now let me consider one simple example here. Okay. Let's say a simple example which we will solve today is to generate the all possible subsets of the array given to you. Okay. So this is the question. The question says that you are given an integer array nums that may contain duplicates. Okay. And you have to return all possible subsets. That is the power set of that nums array. The solution must not contain duplicate subsets. Return the solution in any order. So let's say your nums is given as 1, 2, 3. Okay. What are the all possible subsets? Empty one, only one, only two, only three. 1, 2, 2, 3, 1, 3, and 1, 2, 3. So how many total possible solutions? 8 possible solutions. So you will get 2 raised to n different subsets. Okay, 2 raised to n different subsets of this array, which we called as the power set array. Okay. Now, what if I try to solve it with the brute force approach? So let's say I tried with the empty set. So I have to put one I and I have to keep one j. Okay. I have to decide whether I have to take it or to not take it. So I have different conditions of starting point. Let's say if I start with the 1, then 1, 1, 2, 1, 3, and 1, 2, 3. And again, you need to also check that this should not be an duplicate solutions. Okay, and then if I start with 2, it's 2 and 2, 3, and if I start with 3, it's only 3. So logically, it will take the n square time complexity to put all of this. N square time complexity to put all of this. But you also need to put one. No, it's not n square, right? Because you have to choose. Like if you have choose one, then you can either take 2 or take 3. So it's not this, it's n raised to n then, right? Because you have to choose whether you have to take it or not to take it. With the backtrack approach, we'll reduce it to 2 raised to n. With the 2 raised to n, like, now we have the option to whether take it or to not take it. If we take it, we'll move forward. If we not take it, then also we'll move forward. So we'll call the recursion. So now we have an index I. If I explain you with the tree approach over here, tree approach is the best approach to understand if you wanted to know the backtrack algorithm. Okay, so you have nums array as 1, 2, and 3. Okay, let me make it a little bit shorter and let's keep it 1 and 2 only. Okay, as of now. Okay, so now what you can do for initial 1, okay, currently you have your ith pointer over here. Now you have only two choices, okay, either to take it or to not take it. So I'm putting take options over here and not take options over here. So let's say I have taken this. So currently my data structure has 1, and here my data structure is empty. Okay, if I have not taken it. Okay, again for this, now after taking 1, you have moved to I plus 1. In both of these cases, you have moved to I plus 1, whether you have taken it or not take it. Okay, so now your I is here. Okay, again you have two positions, to take it or to not take it. Similarly, you can take it or not take it. So this become 1, 2. If you will not take, it will be 1. If you will take, if you will take, then it will be only 2, and if you will not take, it will be empty only again. Okay, so you have got 4 different subsets over here. So you have got 4 different subsets over here. Okay, now you got this 4 and you will return it as the solution. Now what does the backtrack means over here? Now we could not have two different solutions like take it or not take it. So we will not call it twice like this. What we will do, initially you will take it, so you will push the 1 in your, you will push the 1 in your data structure. Okay, and you will move forward. Now from here there are no possible paths, so you will backtrack it. So while backtrack it, you will pop 2 and you will come to this initial this you have already pushed it in your answer. So once you got one possible solution, when is the possible solution? When I is equal to n. Okay, so after this 1 and 2, your I will move to I plus 1, which is nothing but n. So now there are no elements in your array. So what you will do, you'll push this 1 comma 2 in your answer array, and you will backtrack this 2. For backtracking, you'll remove this 2 and you will come to this initial position of only 1. Okay, and now you will go to the not take position. So for not take position, you'll not push it into the data structure, you'll just move to I plus 1 and you will not push it. Again your I has become n and you got this as your possible solution, only 1. Again you will backtrack. Now there are no possible solutions to this, so you will backtrack to initial position, which is nothing but empty, which is nothing but at I is equal to 0 only. So at I is equal to 0, now you will come to not take and it will be empty. Okay, again you will take I plus 1 and you will come here. So you chose to take it, so you will get 2 and you will move I plus 1, which is nothing but I is equal to 2, which is out of the bound again. So you have reached your base condition, you will got this answer. After taking 2 and pushing it into your main answer array, you will backtrack it, so you will remove 2, you will came to this empty part, you decide not to take it and you have taken this, and again you will move I plus 1. So this here again a fourth possible solution. So this is how it will work. This is how your backtracking part will work. Okay, so let me explain you the basic algorithm for all this kind of problems, what you have to do. So what we will do, we'll make one data structure, make a data structure like here I made ds. Okay, make a data structure to store current solution, I could say. Make a vector of data structure, which we generally called as answer, to store all possible answers, all possible solutions. Okay, if requirement met or base condition achieved, push it, push your push your data structure to answer and return it. And if not, we'll call recursion and we'll call recursion and backtrack. Okay, so let's solve this in our lead code platform. Okay, so the question says that we are given an array nums that may contain duplicates. So now this may contain duplicates like 1 to 2 over here. Okay, so our solution set should contain the power set, all possible subsets, but it should not contain duplicate subsets. So for 1 to 2, this 2 could be single and this 2 could also be single. So there should be two 2's, but there is only one 2 because answer set should not contain any duplicate subsets. Okay, it could be this 1 2, it could be first one, second 2, or first one, third 2. So there are two 1 2's possible, ideally. But this wants no duplicate subsets, no duplicate subsets. So for not storing any duplicate subsets, we will use initially set so that it will store only the, and we will sort it. Okay, we will sort it and we will use set so that it will not store any duplicate subsets, and then we will change it to final vector of vector answer. Okay, so initially we will store it in our set. So we have one vector of int data structure to store the possible solutions. N is our nums size, and we will have one set of vector of int which is temporary answer, I could say, so that it will not store duplicate, and we will convert it to vector of int while we will return, because returning we want in vector of int. Okay, now we could have one solve function basically, which will have I, which we want as a pointer, and the nums array, the data structure array, and the, let me put it answer only over here, and the temporary answer array. Okay, so now what could be our base condition? So if we have returned, if our I is equal to nums dot size, so I have done everything. Whatever is my data structure, I will insert. So because this is answer is set, so we'll insert this data structure in my answer array and I'll return. Okay, I'll return. So my data structure is now inserted into my answer array. So this is one of the possible solution, like those kind of things. Okay, now what we will do? Anyways, I have initially opted to take it. So if I take the current number, so I'll push back this nums of I and I'll do I plus 1 simply. Now, as I have pushed back, after solving its extension part, I have to backtrack it. So for backtracking it, I'll just simply pop back from there. And no, for not take, anyways, I'm not pushing it. I'll go directly. So no need of backtracking. Because I'm not pushing it, why would I need to backtrack, right? Because I will be at the same position itself. If you have seen over here, if we are not taking it, we are at the same position, like one. So no need to pop back it. Like empty, empty, if we are not taking it. If we are taking it, then only we are inserting something new. So while backtrack, we need to remove it. Okay. Okay, done. So we initially need to sort this nums array first. Then only the same subset would come, right? Okay. So we'll call this solve array starting with 0, nums, ds, and temporary answer. Okay, let's create a final answer array, and we will traverse to all elements under temporary answer, and we will push back in our final answer array. We will return that final answer array. I hope you got it. Okay, this will take the 2 raised to n time complexity, because for each number we are taking either take, not take, not take. So 2 raised to n. Okay, let's submit it. I hope you got. So in the next video, I'll be going to cover the combination sum related questions, which you could see a different category like summation kind of thing under this backtracking. Okay. So see you soon for the next video. Stay tuned, stay safe. If you have liked this video and if you learned a lot, do like, share, and subscribe. Thank you. Bye bye.